Okay, today we're doing exercise 6B, equations with pronumerals on both sides. So it's very similar to last exercise. There's just a bit of extra work because we have terms involving pronumerals on both sides of the equation. So we have to get them all over to the one side of the equation and solve from there. Okay, so the textbook has an example of 7x equals 3x plus 8, and they want you to solve. Solve meaning find the value of the pronumeral. The pronumeral's on both sides, and so we need to get rid of that 3x from the right hand side. The inverse operation to 3x with its invisible plus in front of it is to subtract 3x. So we take 3x from both sides. On the left side we end up with 4x. On the right hand side the 3x is gone, we just get left with the 8. So 4x equals 8. We need to get the x by itself. It's attached to a 4 by multiplication, so we have to divide both sides by 4, the inverse operation, and we end up with x is equal to 2. So hopefully that looks pretty straightforward and you're feeling pretty comfortable. So the big idea here is to solve equations with letters on both sides. First use opposite operations to collect the pronumeral terms onto the same side of the equation. Okay, get that pronumeral by itself. That's the prize at the end of the equation. Okay, let's do the examples from the text. First one up, 8x equals 3x plus 15. Hopefully spotted straight away that 3x is hanging out on the right hand side. We need to get rid of him. We need to do the opposite of plus 3x, which is subtract 3x from both sides. So 8x take away 3x is 5x. And then when we get rid of that 3x from the right hand side, we're just left with the 15. Okay, and we should probably, because it's an example, we should say what we did there, which was to subtract 3x. Okay, we made a big deal of this in year 7, putting these boxes of instructions of what you've been doing so we could track what you're doing. But in year 8, it's sort of getting to the stage where you can get away without explaining what you're doing. We'll put them in for the examples, but I don't mind in your work if you don't have those little boxes of justification for what you did. All right, we're not finished yet. X isn't by himself. He's got a hanger-on of a 5 by multiplication, so the inverse operation to multiplication is division. We'll divide both sides by 5, and so therefore we end up with x is equal to 3. Easy peasy. All right, let's go for B. We have got 5x minus 2 equals 12 minus 2x. Okay, we've got that minus 2x on the right hand side. Let's get rid of him first. We want to bring all the pronumerals onto the left side. So the opposite of minus 2x is to plus 2x. We're going to plus 2x to both sides. And so on the left hand side we end up with 7x, because 5x plus 2x is 7x. We've still got that minus 2, and on the right hand side we have just got the 12, because the minus 2x plus 2x gets us back to nothing. Okay, next we've got to get rid of the minus 2. We always are trying to unwrap the prize of the x by basically doing the order of operations in reverse. If we were going to do some maths involving 7x minus 2, we'd do 7 times x, then we would subtract 2. Because that's the last thing we did, that's the first thing we have to undo. Okay, so the opposite of minus 2 is plus 2, so we're going to add 2 to both sides. And so the left hand side we end up with 7x, that minus 2 is cancelled out by the plus 2, and we've got equal 14. Okay, 7x equals 14, we've got to get rid of that 7, it's attached by multiplication. The inverse operation is to divide both sides by 7, and so therefore we end up with x is equal to 2. Okay, and the next one, we've got 3 minus 4x equals 1 minus 2x. And they actually got the pronumerals on both sides. This time both are negative. So it's not as obvious which way to go. But what we would like to do to just make the numbers easier for ourselves is to end up with x on the side so that its coefficient is positive. To be able to do that, we actually need to be thinking about moving, or not moving, but getting rid of this minus 4x. Okay, so the opposite of minus 4x is plus 4x. We're adding 4x to both sides. So on the left hand side we end up with just the 3. On the right hand side we've got 1, and then we've got minus 2x plus 4x is plus 2x. Okay, and so our x is on the right hand side and there's no x on the left hand side, so we're getting somewhere. Next we need to get rid of the plus 1, so we're going to subtract 1 from both sides. So we've got 2 is equal to 2x. Nearly got x by itself. It's got a 2 times x, so we need to do the opposite, is divide by 2. And we're at the home stretch now. We've got, if we look at the right hand side, those 2's will cancel out and we'll just have an x. So we'll actually swap the order of how we're saying it so we can present our answer. So therefore x is equal to 1. 2 divided by 2 is 1. It would still work if we had have chosen the other side of x. Let's just rub this out and just do the whole thing again and show you what it looks like if we had have done it the other way around. Okay, so this time, instead of adding 4x to both sides, we're going to add 2x to both sides. So the left hand side becomes 3 minus 4x plus 2x is minus 2x equals 1 minus 2x plus 2x is 0, so it's just by itself. Then we want to get rid of that 3 in front of the negative 2x, so we're going to subtract 3 for both sides, and we've got minus 2x equals, so 1 minus 3 is negative 2. Okay, we're nearly there. We've got to get rid of the negative 2 attached, so we need to divide both sides by negative 2. And therefore, x is equal to negative 2 divided by negative 2 is 1. We get the same answer, but it's just a little bit harder for our brains to juggle because we're involving a lot more negatives in our calculations. So it's got a lot more opportunity for error. So it still works out, you just have to be extra careful. So working smarter would be to do the first way that we did, which was adding the 4x to both sides. Let's look at the next one and do it both ways as well. So if we just, the x is only on one side, so it might make sense to just subtract 4 from both sides. So take 4 from both sides, so we've got minus 3x is equal to, so 2 minus 4 is negative 2. Then we want to divide both sides by negative 3. And there we get x is equal to, negative divided by a negative is a positive, and so we're just going to have 2/3. Okay, so that's pretty straightforward, but involving negatives. Once again, we could do exactly the same question. If you didn't like having so many negatives, you could choose to do it in a slightly different order. All right, so we could instead, like the textbook, they've said, I want my coefficient of x to be positive, so I'm going to get rid of that first. I'm going to actually move it to the other side by adding 3x to both sides. So I've got 4 is equal to 2 plus 3x. Then I'm going to get rid of the 2, so I'm going to subtract 2 from both sides. So I've got 2 is equal to 3x. And getting the x by itself, I need to divide by 3. So therefore, x is equal to 2/3. All right, so both ways get you to the same answer. You've just got to make sure you keep track of all the negatives if they're involved. So I actually found the first way a bit easier because there was less moving around, but if you think you're going to make less error by making your coefficient positive, you're free to do it that way. So you've just got to work out what works best for you. The last little bit we've got to do before you can get onto the exercise is check that you know how to check your solution. And it says, when checking your solution by substitution, you should work with each side separately, as in the worked exercise below, as in the one we're about to do. And it says, test whether x equals 4 is the correct solution to the equation 2x minus 5 equals 7 minus 2x. Now it's really important that you don't just chuck the 4 into both sides and say, hey, that looks good. You need to actually do it bit by bit. So let's go and show you how to do it, set it up properly. So we start off with left-hand side equals, and we just write it exactly how the left-hand side is. The left-hand side is the 2x minus 5. So left-hand side equals 2x minus 5. Then we put in the substitution that we're checking, and we're checking x is equal to 4. So we've got 2 times 4 minus 5. 2 times 4 is 8, minus 5 is 3. Now we can't straight away check with the right hand side and see if it matches, because the right hand side involves needing some work as well. So separately we'll go right hand side equals, and we've got as it is 7 minus 2x. Then we'll do the next line putting the substitution in, 7 minus 2 times 4. 7 minus 2 times 4, so 7 minus 8 is negative 1, which unfortunately does not equal the left-hand side. So if the right-hand side does not equal the left-hand side, then we've got a problem. It's not a solution. So we conclude, therefore, x equals 4 is not a solution. Okay, let's try the last one. Another one to test. This time testing whether y equals 3 on 2 is the correct solution to blah. Okay, 3 on 2, fractions, your favourite. Can't wait. Let's go left-hand side. Equals, and we'll just write it as it is, 15 minus 5y. Then we put in the substitution, so 15 minus 5 times 3 on 2. And so then we have 15 minus 15 on 2. So 15 minus 15 on 2 would be the same as 30 on 2 minus 15 on 2, which is 15 on 2. Okay, can't directly compare that with the right-hand side yet. Let's now do some work on the right-hand side. Right-hand side equals, now as it's written, 6y minus 3 on 2. Then putting the substitution in, 6 times 3 on 2 minus 3 on 2. Okay, multiplying our numerators, so we've got 18 on 2 minus 3 on 2. And 18 on 2 minus 3 on 2 gives us 15 on 2. Oh, exciting times. That looks familiar. That is our left-hand side. So it equals to our left-hand side. So we can confirm that, therefore, y is equal to 3 on 2 is a solution. All right. That is it. That's all you need to know to have some fun in exercise 6B. So I'll put the questions on Schoology and I'll leave the Zoom open so you can come and ask questions if you get stuck. Okay, have fun.